Alright guys, 9.4 homework. Hopefully watch the videos on the lesson. I'll give you some homework help here. Alright, so we're going to do 1 through 14, so let's start there. I'll take some screenshots and then go from there. Okay, so we got 1 through 14. Let's come down to the bottom here. Oh, that's a little big. Okay, so here's numbers 1 and 2. The directions are find the tangents of the acute angles. Okay, so angle R is acute, so the tangent of angle R is going to be the opposite side, which is 45, over the adjacent side, which is 28. Okay, when we talk about opposite and adjacent, remember the hypotenuse is never referred to as the opposite or the adjacent. The hypotenuse is always going to be the hypotenuse. Okay, we'll see the hypotenuse in action in the next section when we talk about sine and cosine. When we talk about tangent, it's always going to be the opposite over the hypotenuse. I'm sorry, opposite over the adjacent. So that's one acute angle. The second acute angle here is the tangent of S, and the opposite of S is 28, and the adjacent of S is 45. So if you notice there, the similarity here is just the tangent of each acute angle is a ratio of opposite over adjacent. So one acute angle is 45 over 28. The second acute angle is just going to be the reciprocal, which is 28 over 45. Alright, so same thing here. So the tangent of, again, I'm not going to use E, I have to use the acute angles. Tangent of D is going to be opposite here, which is 7. And the adjacent to here is going to be 24. And once you know D, then you automatically know F without even looking at the diagram. But let's look at the diagram anyway. So I'm looking at F. Opposite of F is 24. And the adjacent for F is 25. It's going to be 7. Okay, because 25 is here's my hypotenuse. So that's not going to come in play here for the tangent ratio. Alright, what else we got? We got number 3 and 4. So I'm just going to snip these. Alright, similar situation here. Yeah, whatever. So we have the tangent of the acute angle, tangent of G. It's going to be the opposite. So tangent of G is going to be the opposite, 2 over the adjacent, and the adjacent is going to be 1, so tangent of G is just tan of G is equal to 2. And the other acute angle here is H, so tan of H is equal to the opposite, which is 1, over the adjacent, which is 2. And again, once you know the first one, then the second one is just going to be the reciprocal of the first acute angle. So you can shortcut that if you like. Okay, and then the next one here. Tan of J, opposite over the adjacent. So when I'm looking at K, without even looking at the diagram, if I'm confident in J, then this is just going to be 3/5. And again, I could verify opposite, my numerator, adjacent, my denominator. And there's 1, 2, 3, 4. Okay, let's deal 5 and 6 here. In 5 and 6, find the value of x. No problem. Okay, so find the value of x. So here I have the angle. So I have the tangent of 41 degrees is equal to opposite over the adjacent. Okay, so I'm going to do a little math here on the side just to show you the algebra behind this, or the pre-algebra behind this. So let's just say this was 6 equals 5 over x. How would you solve for this? Well, I'm going to multiply both sides by x so I could clear my denominator. So now I have 6x equals 5. The same expression, right? Just working without fractions. And then I'm going to divide both sides by 6, and I get x equals 5/6. So I'm going to apply that here. So I'm going to multiply both sides by x, and I get x times the tangent of 41 degrees is equal to 12. Well, I don't want x times the tangent of 41 degrees, I just want x. So I'm going to divide by the tangent of 41 degrees to both sides. And I get x is equal to 12 divided by the tangent of 41 degrees, which I'm going to put in my calculator. 12 divided by tangent of 41, and I get about 13.8. Alright, and then, so I'm going to get rid of this, and now I'm going to do the next one here. Alright, and we have, okay, so we have the tangent of 27 degrees is equal to the opposite over the hypotenuse. Opposite over adjacent. Right, now we're using the hypotenuse for tangent ratio. And this one's actually going to be easier. I'm going to clear my fraction, same technique. But when I clear my fraction, I get x equals, which is already set up for me. X equals the tangent of 27 degrees. So x approximately equals 15 times the tangent of 27 degrees, which is about 7.6. Alright, so there's that. 5, 6. We got 7, 8. Take those. So those are going to be similar to these. Alright, I'll just do these out with you guys. 7, 8. So again, here's my angle. I have the opposite. I have the adjacent, which tells me to use the tangent ratio. So that's how I'm deciding whether to use tangent, sine, or cosine. But obviously you guys have only done tangent so far, so we're using tangent. But it's when I have the opposite and the adjacent, then I know I need to use the tangent ratio. And this is going to be the same thing here. So multiply both sides by x. So I get x times the tangent of 58 degrees is equal to 22. Remember, this is all one term here. And then I'm going to divide by that one term of tangent of 58 degrees to both sides. And you get x is equal to 22 over the tangent of 58, which is approximately equal to 13.75 if you're rounding to hundredths. Alright, and then again here, I got tangent 37 is equal to the opposite over the adjacent. And I'm going to shortcut this one. If you notice that, see how the tangent and the x, and like, they're just really just swapping positions. So this is going to be x is equal to 6 over the tangent of 37 degrees. So if you notice it here, I'll try to highlight this for you guys. So tangent is my numerator, x is my denominator, and then when I do the little math here, x is my numerator, tangent is my denominator. So they're really just switching positions here. Right, let me see if you guys can color code that a little nicer. So numerator, denominator, denominator, numerator. So I'm going to use that same shortcut here. Numerator, denominator, which now becomes my new numerator and my new denominator. Just a quick little switch. Alright, so again, after you've applied the algebra a few times and you come up, you can see that it's great. Alright, so I'm going to plug that in. 6 divided by the tangent of 37 degrees. And x is approximately equal to 7.96. Alright, so there's the first 8. Let's do 9, 10. Alright, so 9 is tan of d is, okay, so tan of d, so it should be the opposite, check, over the adjacent, not check, that should be 12. Right, we're not using the hypotenuse. 37 is the hypotenuse, we're not using that. 10's a little trickier here, so it does look like, here's your tangent, there's your opposite, check, there's your adjacent, check. But there's actually an issue here, so here's the issue. If you plug in the tangent of 55 into your calculator, you get approximately 1.43. Remember, the tangent of 55 should equal 18 over 11 as a fraction, otherwise they're not equal. So if I plug in 18 divided by 11 on my calculator, I get 1.64. 4 approximately. And these two are not equal to each other, so therefore there's some kind of, maybe the 18 shouldn't be here or the 11 shouldn't be here, but there's some kind of a mix-up in the angles here. So these ratios are not correct for this angle measurement. We can find what this angle measurement could be, or this is not a 90-degree triangle. Like, we could find this, and we will find this in the next couple lessons, but not yet. Okay, but the bottom line here is the tangent 55 degrees, that decimal should equal the same decimal as the ratio of 18 over 11. Alright, number 11, 12. Okay, so this one. I use special right triangles, so here's my special right triangle. So 90, 45. So this is x, this is x, this is x radical 2 for my special triangles. It says use the special right triangle to find the tangent of the given angle measurement. So, well, tangent of 45 degrees would be the opposite, which is x, over the adjacent, which is also x. So the tangent of 45 degrees, x divided by x, 5 divided by 5, 10 divided by 10, anything divided by itself is 1. And if you're questioning that, if you plug that into your calculator and put the tangent of 45 degrees into your calculator, you will see that tangent of 45 is actually 1. Okay, and then the next one here. Let's say that's my 30. So the hypotenuse is 2x, or twice the length of the side opposite to 30, and then this one's just going to be x times the square root of 3. So if I consider the tangent of 30 degrees, well, there's the angle, opposite over the adjacent. So this is just going to be the tangent of 30 equals, well, x over x it's 1x, will simplify, so you get 1 over the square root of 3. And if we remember how to rationalize the denominator here, we're going to multiply both sides by the square root of 3 here, so I can turn this into the tangent of 30 is equal to square root of 3 over 3. And if you verify that, am I correct? So I'm going to plug in the tangent of 30 degrees into my calculator, and I'm going to get approximately 0.58. So 0.57735, blah, blah, blah. And then just to confirm that I did this correctly, when I put in the square root of 3 divided by 3 in my calculator, I get the same approximation of 0.58. So that is correct. Okay, so the tangent of 30 degrees is 0.58, which is similar to the ratio of this radical 3 over 3. Alright, so that's your first 12. What else we got? First 14, we got to do 1 through 14. Okay, 1 through 14. I'm going to white this out here, or got that white out already. 1 through 14, 17. Okay. Okay, cool. So here we have, we're looking for D. So here's my triangle. And I have a 55 degree angle here. So I can write the tangent of 55 degrees is equal to the opposite, which is going to be D, over the adjacent, which is going to be 500. So clear my fraction here, multiply both sides by 500. So D is equal to 500 times the tan of 55, which is approximately equal to 714.1 if you're rounding to the tenths place. Estimate. And then we got number 17. Yep, find 17 here. Let's see. How does the tangent of an acute angle change? Well, that's a great question. How does the tangent of an acute angle in a right triangle change as the angle measures increase or decrease? So I'm going to come back to this one. So the tangent of 45. So we said the tangent of 45 degrees is 1. So what happens when you have the tangent of 30 degrees or the tangent of 60 degrees? So to get 1, there's going to be some ratio that's 5 over 5, or the ratio has to be the same. Like your legs has to be the same, which is why I worked on a 45 degree triangle. So in a 45 triangle, I'm come back to this one where it was. This is x radical 2, so this is 5, 5, and 5 radical 2. Well, when I take the tangent of that angle and I do the opposite over the adjacent, well, that's why I get 5 over 5 equals 1. We said the tangent of 30 degrees here, when we plug that in, is approximately equal to 0.58. Right? We said the tangent of 30 degrees is square root of 3 over 3, or approximately 0.58. And what about the tangent of 60 degrees? Well, we could come back down here for a second, and if I look at the 60 degree one, right, this is going to be my 60 degree angle. The tan of 60 is going to equal the opposite, which is x radical 3, over the adjacent, which is x. So the tan of 60 is just equal to the square root of 3. So when I come back here, tangent of 60 is equal to the square root of 3, which is equal to approximately 1.7. So at 45, it's going to be 1 as the angle decreases and gets closer to 0. You're getting closer to 0, and as the angle increases, getting closer to the 90. Right, this one's going to get bigger and bigger. This decimal is going to get smaller. This decimal will get bigger and bigger and bigger. So how does your change? If you have a 45 degree angle and you're decreasing below 45, your decimal is going to decrease. If you start to increase above 45, your decimal will start to decrease depending on the value of your angles. Okay. And what else we got? 19, 21. 19 and 21. Okay, so we got so you're having a class, your photographer is positioned 14 feet away from the center. The photographer turns 50 degrees at either end of the class. Okay, so here's my original triangle 15. Your banner is 28 feet long. If the class is arranged as shown, can the students hold the banner so it stretches? So the banner is 28, so I need this whole thing here to be 28 from here to here, assuming it's 50 degrees. So let's figure out this. Let's figure out this side first, right? Because I could do that. So I have the tangent of 50 is equal to the opposite, which is my unknown, over the adjacent, which is 14. So x is going to be 14 times the tangent of 50, which is approximately equal to 16.68, and I'll multiply that by 2, and I get, so this whole thing is about 33.37 if I do that. Okay, so will it work? Yes. Okay, then a group of students arrive late, so the photographer turns another 10 degrees both ways. Okay, so now we're looking at a triangle here. We're looking at this triangle here with 60 degrees. because you add another 10, okay? If each student needs 2 feet of space, so if each student needs 2 feet of space, how many more students can be arranged? Okay, so let's see what we have here. So this is still going to be 14. We said this, half of this is 16.68, right? We got that from there. So this time we're going to do tan of 60 degrees equals 14 over x. So x equal to 14 tan of 60. And tan of 60 is increasing, so 14. So 14 times the tan of 60 should increase as well, as we saw from the last example. So this is going to be approximately 24.24. So on one side, if we have 16 plus 2 feet, that'll give me 1 student. That will give me 18. So we got 16.68. I need 2 feet for 1 student. That's 18 plus 2 feet. That's 20 plus 2 feet. So we got 16.68 plus 6 equals, so far we have 22.68. That's for 1, 2, 3 students. And if we add another 2 feet, it brings us to 24.68, which is bigger than 24.24. So we can't do that 4th student. We could do 3 students on the left, 1, 2, 3 students on the right. So we could do a total of 6 students. Fun problem. And that's number, there it is. It's number 19. We got 21 and 23. Okay, 21 and 23. Let's see what we got here. For what angle measures of a tangent of acute angle is equal to 1? Oh, so we saw that before. So tangent of 45 degrees is equal to 1. Greater than 1 is anything tangent of 45 degrees to 90 degrees, and it's going to be greater than 1. And the tangent of 0 degrees to 45 degrees is going to be less than 1. Actually, it'll be less than 1 but greater than 0. So it'll be less than 1 but greater than 0. X being the tangent of any number of degrees less than between 0 and 45. Alright, and then number 23. I'm going to stop there. I'm going to let you guys try to figure that one out. Fun problem to just try to do on your own. And if you're really stuck, give me an email, shoot me an email, and I'll do a separate video for that one. Alright, good luck.